I'm Kelsey Weidman.
I'm Jeffrey Ton.
And I'm Colin Bromstead, and the three of us are seniors in electrical engineering at the University of Vermont, and this is our wireless sensor network project.
We are doing our project on the extremely opportunistic routing algorithm, which is an ad hoc, that means self-configuring routing algorithm.
The project we chose to explore incorporated the extremely opportunistic routing scheme. In this scheme, nodes are able to communicate with each other and decide and implement the most effective path for each transmission. This path can be determined using multiple approaches through priority tables, proximity to destination, signal strength, and any combination of these. Additionally, the network can be self-healing if a change in the environment were to occur, such as a partial or total obstruction of the path. The topology we implemented used a sink and a source with 4 remote nodes in between. The source sends out the data packet to all the remote nodes. The remote nodes collect the data packet and begin communicating between one another. Each node has a node ID associated with it. This ID is compared to an internal priority table. During this conversation, each node will communicate with every other node who received the data packet. Once a node discovers it does not have the highest priority, it drops out of the conversation. Whichever node is last has the highest priority and will then forward on the original data packet. As you can see, node 4 has dropped out of the conversation due to the fact that nodes 1, 2, and 3 all have a higher priority. Node 3 has now dropped out of the conversation due to the fact that 2 and 1 have higher priority. Now 2 has dropped out of the conversation, leaving 1 with the highest priority. Now that 1 is determined to have the highest priority, the source sends out a stop bit to all the nodes, telling them to stop the acknowledgement and to now start the transmission. The only one that will do the transmission is node 1, since it has determined that it has the highest priority. Now 1 forwards on the data packet to the sink.
So you can see here, this is a conversation that 3 nodes are having. The one that's staying lit the longest has the highest priority, and therefore is going to be the last one standing and finally going to be the one that transmits the data.
This is a shot of our source node. It sends out a data packet when we strike the enter key. That data packet will be sent to our first cluster of remote nodes, and there they are. That is, and they have a priority of 3 and 4, or IDs of 3 and 4, and so when they will have a discussion amongst themselves after they receive that data packet, and 3, since it has the lower priority or the lower ID number and hence higher priority, will forward the packet onto this next cluster of nodes. And here we have nodes with IDs 1 and 2. And they will then have a discussion upon receiving the data packet that was forwarded from 3. During the course of their discussion, they will decide that the node 1 will transmit the will forward the data packet, and that data packet will then be sent here to the sink, which is attached to a laptop. Right now we're looking at a screenshot from my laptop, and this shows the topology of the nodes. It's a graphics program made in processing, and what we're actually going to do is take serial data or data from the serial port of the base node and use that to display the path that the data packet took as it moved through the network. In this next shot, we see that the data was sent from node 5, which is the source node, and it went from node 3 to node 1 to node 0. The node 3 and 1 had the highest priority in their respective clusters. In this final shot, we have removed, we took node 1 and node 3 offline, so now the algorithm had to figure out a different way of moving the data from the source to the sink and went through node 4 and 2. Here we see the topology of a simplified network. This is to display in more detail how the communication process goes between the intermediary nodes as they decide who is going to forward the data packet. In the top we see the source. There are the 3 intermediary nodes in the middle, and here we are now looking at the base node, which is attached to a laptop. Here we see the 3 intermediary nodes. They've received the data packet and they are communicating amongst themselves. You see that they all 3 blinked, and then one right here will send out an isolated single blink, and that means that it has been chosen to forward the data packet.
So you can see here that node 1 has been disabled. Node 1's disabled, 2 and 3 still receive the data packet, and they communicate to CO as the highest priority, and number 2 figures it has the highest priority and then sends the packet. So as you can see here, node 2 has been disabled, leaving node 3 as the only one to receive the data. Once node 3 realizes that no one else has acknowledged that they have the data packet, it then forwards the packet to the sink.
Here we see the topology of the network. On the upper right-hand side, we have node 4, which is the source node, and then we have 3 intermediary nodes, nodes 1, 2, and 3, and in the bottom we have node 0, which is the destination node. As you can see, the data is going from the source node through node 1 to the destination node, node 0. After we knock down or take out node 1, the data is now routed from 4 to 2 to 0, and then we will knock down node 2, and you can see that the data is now being forwarded from 4 to 3 to the base.